Ahoy, peoples. In this tutorial, I'm going to be going over I guess, a more efficient way of doing a Blendshape node. There was a discussion on the other tutorial that I'd set up for setting up a preset on a point node to do whatever attributes that you want to blend. Because I'm still a fan of that method, but I thought that could be redone. There was a conversation in the comments on ways that we could do it with Python or Vex or just a different way of doing it. And I thought I'd come back in and make an actual HDA for it. And so just kind of a rebuff or whatever it is of what that tutorial was going over was taking a point node and then using a arbitrary parameter to drive, I guess, in this case, the point position of the input 1 and the point position of the input 2, which, I mean, input 0, input 1. So you have the position coming in and 1 minus the blend. So if it's at 0, it's going to be 1 plus the op input 1 position, which is the second input, and multiply that by the blend itself. So you can end up getting a pretty nice blend between things, like that old screensaver back in, I don't know, the 90s. Woo! Okay, but you know what? It's not fun. It's not as robust as it could be. So, like in this case, you need to have the exact same geometry coming in, and I was thinking it might be kind of cool to actually like mess with that and try to achieve two different geometries that are blending between each other. So over here, I have the box coming into a normal, just to create normals on it. And I have a little create attribute just for the sake of something to test in, after this. A sphere that's coming in on the other side and a attribute that, just an eye test. So these are two attributes that I'm going to attempt to blend, and I'll show you how to do that. So what I want to do, just right off the bat, put down a wrangle node. Attribute wrangle is maybe not as great of an option for some things, but it's better than others. So like the point wrangle has some aspects that it just seems to work a little bit better on how it's running over the points and evaluating attributes. But we're gonna do attribute wrangle for blending attributes of arbitrary types. So what I'm gonna do with here, I want to get a couple of pieces of information. I want to be able to have a slider that we can blend with. And if you saw the other tutorial, it doesn't really matter. I'm also going to add a ramp. So I'm going to add these two things right now. If you go into the edit parameter interface on the actual wrangle node, you can just drag in float values or parameters or whatever it is that you want to actually modify. So in this case, I'm going to put down one float parameter. I'm going to call that blend, I guess. Doesn't really matter. You can name it whatever you'd like. It's to each their own. And then I'm going to say ramp or multiply ramp, just to have some sort of sense of continuity for being able to look at this later and understand what I was thinking. I'm just going to hit apply, and then you can hit accept. You can get out of there. So first thing I'm going to do, just right off the bat, is let's just get positions blending, right? But since they are different geometries, I'm just going to get positions blending for the sake using that. I raid the cube onto a sphere and then smooth it a little bit, and just for the sake of showing something working here. So what I'm going to do is vector the to position to pos equals attrib, and you can put in 1, which is the second input, so what's reading here. And then I'm going to say I'm reading a point attribute, and that attribute is p for position. And I'm going to read the current pt num. Now pt num, if you're unfamiliar, is the number of the point that is currently iterating over, because you notice it says run over points. So it's currently running over every single point of the, I don't know how many are in here, 386 points that are in here. Sounds good. So after this, I want to get a blend value. So I'm going to say vector blended. It's easy. It's splendid because it's blended. All right. I'm just going to read the v at p, and that's the current point position that this node is iterating over. Oh, you know what? Right before I do this, because it'll save us some time, I'm going to say float blend val equals CHF. Now, the reason I'm putting the F in there is in Vex, it makes it a lot easier for knowing what parameter is being read, like the type of parameter that's being read. And I'm going to type in blend, which was the float parameter that we had put in. So I'm going to say VIP times that same setup that that I showed you on the point node, blend value. So 1 minus blend value, and then I'm going to add I'm going to add 2 position, 2 pos times blend value. Now, just for the sake of showing you what this is doing, and then just make sure you actually write this out. V at P equals blended. Super splendid. Oh, well, there's an error because I'm saying value instead of, you know what? That makes sense. I'm just going to do it because why the heck not? All right. And in this case, you start blending it, and you get a nice little range going on. Look at that. And you notice the point normals are staying the same, which is optimal in this case because we only want to blend position here. But we want to expand this out. We don't want to only blend position. We want to be able to blend any attribute. Oh yeah, don't worry about what I'm doing right here. I'm just changing the defaults here. I'm just going to make it -1 to 2 on the blend parameter that we'd set up. That way it makes it a little bit easier for going negative values and everything else. Anyway, but we want to blend more than just position. So I'm going to set this up as a subnetwork. That little button right here sets it into a subnetwork. Now the reason we're doing that, you can right click on it and say create digital asset, which is a beautiful thing because then you'd be able to load it in whenever you like, and it makes it all nice. So this is a attribute-based blending, but it can do just about anything. So I'm going to say it's a geometry editor, and you know, name whatever your naming convention is, and it is a attribute editor. Name it whatever you like. Attriblender. I'll take it. Attriblender. I dig it. All right. Wait. No. Straight up. Attriblender. All right. And then Attriblender. Go for that. Geo, Attriblender. Sounds good to me. I'm just going to hit accept, and that's going to turn it into into an HDA for us. And that's beautiful so that we can just put it down whenever we want in the future. Attriblender. Easy. So I know I'm a little attached to that name, I think. All right. So we need a couple of things. We want to find attributes that you want to blend. You want to be able to have those blend ramp and the float attribute that we'd set up. So if you dive into your network, what you could do on the node where it says blend, just grab it and drag it directly into the window. And I think it takes the default value. Yeah, it takes whatever the value was that you had currently set. So I'm going to set this to 0. So there's no blending at all going on. And then if you hit apply, you notice it updates and goes that kind of green color or whatever color that you've set it up to. And then I'm going to also dump in that multi ramp. So I'm just going to say multiplier ramp. Okay. And I'm going to say blender. All right. So that's going to be giving us the core, the base parameters on our HDA. So I'm going to go back in and go into type properties, bring the window back up, and I'm going to add a couple of things that are going to be useful for us in the future. Now, we need to have a list of the attributes that we want to blend, but I also want to be able to blend by an attribute because we have, you know, it's a linear thing. It might be kind of restrictive to only have it be 0 to 1 if it's affecting the entire mesh all at once. If we have like a custom attribute that we want to drive these effects, I can only imagine that this would be helpful for me. It might be helpful for you. I don't know. I'm going to do it anyway. So adder, I'm going to say adder blender attribute. Blender. That sounds kind of redundant now, doesn't it? Because this is the attribute blender, but it is the blender aspect. You know what? Doesn't matter. Target. Attribute target. Attribute blends. I don't know. I gotta change. You know what? Attribute blends. I'm gonna change attribute blender, attribute blends. This sounds really redundant now, doesn't it? And also, I'm gonna stick with a value. You know what? Okay, whatever. We change the names whenever you want in the future. It doesn't really matter. But let's just get going. Now, what the first one is that I'm gonna go with, the attribute blends, are gonna be the attributes that you are currently blending between the two different inputs. So if you go to the menu tab on with it selected and say use menu and go to menu script, we're going to set this up to be reading both of the inputs, and that way it knows it can actually blend attributes that both inputs share. So it won't be listing some attribute that only one has, and then you end up being confused. It's like, why is it not doing anything? So you know what? Might as well just nip it in the bud before it becomes something annoying in the future, right? So what I'm going to do is say n equals who.pwd, which is the current path of the node that is being worked on. And then I'm also going to say geo equals n.geometry. Geometry. And it's turning red because you need to hit apply. Why? Because it's going to be erroring out. Of course it's going to be erroring out. I'm going to send you to, oh my. So the reason that was erroring out is because it's not returning anything. In case we do want to have this in the future and just to test, if you do return and give it a array with two different entries. I know I've said it before. It doesn't matter. The first entry is the label or the value. The second entry is the label. That way you can, it'll actually list 0 and it won't error on us. Because if I hit apply, you notice that not more errors were showing up. But you see it says 0 and 0. It's, nevertheless, on here, oh, you know what? Because this is a pull down like this, I want this to be a multi-selection so that in the future we can just blend as many attributes as we want. All right. Preface to be ended. Okay. Now we need to get the list of the attributes list of the actual node that you're currently working on. So I'm going to say geo dot point attributes. So what this will do is list all of the point attributes found on the geometry for you. And we can just test this out by doing a little for loop. You can say test a in atterlist. And I'm just going to say print a. Now this should print out kind of strange. There you go. Yeah, you notice that it's printing out as like an object or a attribute that it's reading from the object. And it says np blur and itest. So you see it says n of 3 floats. And, blur is 1 float, and you see 1 int. Now, I like the idea of it only blending between floats and integers, because I don't know how you'd blend strings. That would be a very cool thing to see, though. What would be the use for that? I don't even know. However, here, let's just add a test so we can see that it's actually working in the future. Let's restrict any strings from showing up. I'm going to say string test, and I'm just going to set this to a string. No, not a string array. I'm going to set this to a string test, and I'm going to say blah, 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 blah. It doesn't matter. It's just it's the test all together. So now if we go back to this and we click on the pull down again, you'll notice that now there's a string test and it says 1 string. So we need to do a few things here. You notice that it's not actually like a name that we can read. Like you can't humanly read this. So we need to do something called name. Simple enough, it'll just print out the attribute name for us. Then on top of that, we also need to get the data type of what the actual attribute is. So it's very simple. data type. But then you need to do name because it's also going to print the data type in the same type of Python. I don't know how you call that. It's an object. So the data type object has a name attribute that you can call. Then I'm also going to do print of A, and here's the kicker. We need to get, oh, no, you know what, that should be fine. I'm just going to do this. I'm going to show you what this is doing. If I hit apply, do the pull down again, and you notice it says string test, string, itest, int. It's easy enough that it's printing out the attributes for us, and then we're getting the types. So we can say, I don't know, name equals a name, and then we can say type equals data type. So if you're familiar with Python a little bit, we could do something a little snazzy on this. We can say if type in, and then make it an array that you're giving it. You can say float, and you can say int. And if it's in there, so it's going to be calling out everything else. And it should be said, if you notice, the n also returns as a float because it's a float size of 3. So vectors will also show up as floats for you. So in this case, you'll have if type, which is the data type that we found, is in this array, which it's either going to be a float or an int, then we're good to return it. So we can say, I need to make a return array. So I'm going to say ret equals a blank array. And then I'm going to do ret.append. In Python, if you do append to an array type, you'll be able to add it append it to the end of the array. Now, if you notice, like I said before, you have the label and then the actual name, the value and then the label. Sorry. So if we do 2, which we'll need to do for every single entry, you'll be able to get the name of the attributes that it's finding. And if we change return back to ret, the array that we'd set up here, it'll list all of the attributes that's here for us. So I'm going to hit apply, and I'm going to see it doesn't have that string test attribute. But since I know for a fact some of these do not exist on the second input, we need to make that correction here. So here's what we're going to need to do. Yeah, actually, we're going to need this script for the attribute blender. So here's what I'm going to do. I'm just going to copy this and go into the attribute. You know what? I'm going to say blend by attribute. Ha! See? Easier. Not as convoluted. Yeah, see, blend by editor. See, it makes it a little easier. All right, whatever. I'll stop. If you go back to your menu, same menu script, hit paste, and make sure you set it back to Python. Now, we're going to need this in the future, so I'm just going to hit apply and go back to that initial attribute blends that we're setting up here. Now, we need to do this basically the same thing for the second input. Now, we can do this a couple of ways. I'm going to go, all right. I'm going to say second in to geo. Yeah, you do it that way. Now, we could do n.inputs, and that's going to give us the inputs that are actually coming into the current node that we're working in. And if we say 1, if I can type. If you say 1, it'll be the second input that's coming in here. And then this way we can do the same thing that we did down here. We can do point attribs and do it like that. And to adder list. I'm going to just make it like this. Now you notice this is doing all of this in one line, and I do need to call the geometry of this. Do remember the geometry, a tree, is what has the point attributes on it. So you need to call the geometry object and then read the point attributes from the geometry object. There will be the problem that you might be foreseeing right here. You notice how we need to call the name because it was some crazy, not so readable objects? Those two objects can't be cross-referenced. well, straightforward can't be cross-referenced because they're going to be two different. They're from a different object. They're from a different location. Like you notice it says P and it's coming from the Geo1 Ray 1, and that's this node right here. So it found it, but it's not something that we can read too legibly. So we need to kind of correct this list a little bit. And there's a neat little thing that I don't see used as often as I would like to see it, but maybe it's just me being like, Python. There's something called a lambda. Now there's going to be an attribute, there's going to be a function I'm leaving out right here, but just to show you what lambda is. Lambda is basically a for loop that you can do anything to, and it's all in one line, and you don't need to worry about anything. So if I do, well, I'll just, okay, if you, like this, and let me explain. Lambda is the for loop. X is going to be the variable that it's assigning for every single object in the array that you're feeding it. So if I do x.name, it'll return the name of every object that's in this array. Now, there's something that we need to do because there's a few different ways that you can use lambda. One of them is a filter, which is basically you can cull things out or assign values or something. What we're going to do here is map. Now, map is going to basically take those that basically every entry, the name of it, and it's going to map it to the same value that it's running through this array. That sounds a little bit convoluted, and I will show you, you know what, I'll show you right after this the for loop way of doing it. But you notice if you click on the pull down, we're getting P and N because it's returning just the name. So let's say you didn't want to do this in Lambda. How would you do it else in a different way in Python? You can say for a, it doesn't really matter, attribute, whatever, in to attribute list, and you would say, ooh, that's a different one because you could do it in a, let's say to new array. Just to be simple. There's ways you can get around it without making another array, but I don't feel like doing that right now. But you can say for a in to attribute list, and I'm going to append a dot name, and I'm going to then print this. So if I hit apply and click again, there is an error because string does not have name. Oh. Because I'm already converting it up here. So just to show you, you're getting the list of attributes here, and then setting up a new array, and then in a for loop, just to return the name of the array. So hit apply, and then hit down again, and you notice it's printing it. Now that's, you know it works, but I'm not a fan. Come on, I want it to be one line. I don't know. Lambda just seems like it's a quick, easy thing. It's easy for me to just see, like, I'm mapping the output of the array that's being ran over for every single one name. It just makes sense to me. Nevertheless, you can do it either way. Again, you saw the same result. So why am I doing this? Why am I doing this already? We have the names. We need to cross-check. We need to cross-check the names. Well, we could do it right here, the for loop way, or we can do it the fun way. Like I consider lambda fun. Now, you know what? Just be simple about this. If type is in float array, and then I'm going to say and name in. We're doing quite literally the same thing. It's just another array that it's looking for. So that name that we just find, because it's doing the same thing, P and N or whatever, is in the array, then we want to add that to the return array. So if it's not in both, then we don't need to worry. See, now you only have N and P. Let's get this blending some attributes. Why don't we? Make it simple. For for the blend attribute, I know we blend by attribute. You know what? Yeah. Why don't we set this up while we're in here? Now we only really want to blend by floats, and I mean, as neat as it might be to blend by a vector, I could see that becoming more of a problem in the future than helpful. That being said, I had mentioned how a vector is basically a float size 3. There is something on attributes, called size. Very straightforward. And if a size is of 1, then we want to list it. So if float equals net and size equals 1. And so what this is going to do is do the same thing. It'll grab the attributes, run through them all, grab the data type to see that it's a float, and then it'll grab the size, which will be 1 if it's actually a float, or 3 if it's a vector, or I don't even know if it's a float array, it'll be huge, you know, whatever it is. And then we just want to return the name. So I'm going to hit apply, no errors, and blur is currently listed, and blur, I guess, is the only float I have on here, which I guess is true. And, you know, let's just make another one for the hell of it, just because. Another float. Why not? I'll just do pdnum. I don't know, just give it some sort of input. And if you go back on the node, let's see what this does. Yeah, another float. How about that? All right, so why don't we get back into the core of the actual node itself. Just hit accept, save out, clear this window, close that, all this map. As I start fummaging around and screw up everything here. Okay, so if you dive into the Attriblender, you're gonna have kind of a static setup here. It's only running on points, point position, and it's only running on point position, and it's only setting point position. However, we now have the attributes that we want to blend, so I'm going to set these just for some example settings. We're going to just stay with the blender parameter for now, and then we'll get to the blend by attribute later. So why don't we just get this working just for the base of it all. Now, there is a few different ways to go about this. Some of them are a lot longer than others, and others are kind of simple. So I'm going to go with the simple method that might not seem too... well, I mean, okay. Here's what we're going to do. We want to get all of the attributes that are listed. So you know what? I'm just going to hit copy parameter. Come down here, paste parameter. Oh yeah, and I saved this, but I want to keep the blend. This value, it doesn't really matter. Blended, it doesn't really matter. But I'm going to keep all that. Now there's something, however, that we need to address here. This is going to be attributes attrblends equals the string of the attriblends that we have above. But since we don't know, we're keeping it only between ints and vectors and floats. So we don't know what we're working with. And if you need to read an integer, you need to read a float, you need to read it gets convoluted that you can have so many entries. There's duplicate code, and it's kind of annoying. So we're going to go the lazy route. I don't know if this is really lazy, but if we do float read, I guess it's whatever the value is that we're going to read, and I'm going to say bracket. Now, this might seem a little annoying or strange or confusing, or I don't really know, but if we do... Alright, we're going to do string. Oop. This also needs to be a string. Set this as a string. String split. And what this is going to do is split our attr blends by space. And that will work for us because all of the attributes have spaces between them. So what it's going to do is it's going to break them into an array of n and p, or whatever attributes are in here. So jump back in here. Split is not working. Why is split not working? Let's see. Split is string and string, but it goes to so it goes to a string array, as I just said. So you need to make sure it's outputting to a string array. And then on here, I don't know why that got pasted there. All right. So what we're gonna do, move this down a little bit, and I'm doing a float read. Now it's kind of strange. Wait a second. I'm gonna do read the here, just so we can get our integer reading as well. But there's no n. You notice that? So this is not gonna actually work, which actually is a good thing to have in there for the time being. So here's what we do. For every single split, we need to iterate over. And I'm going to read leave this as a empty float read. It'll be our reading value of the second input's whatever attribute is. And there's a reason I'm going to be leaving it as a float string, a float array. One sec. We're going to need a for loop to go over equals 0. All of the x is len. I think it's len. I keep forgetting between len and length. Len of split, which will get the length of the split, which currently is 3 because we have the n, the p, and the I test. And then I'm going to say plus plus x. It could be x plus plus. It doesn't really matter. This is just a habit of mine. And this is going to currently iterate 0, 1, 2. So it'll run through every single one. So why don't we just print out some values just for the sake of seeing what it's doing for us. So I'm going to do print /n and g. And I'm just going to put in split of x. And so what this is going to do is a print command. This is printf. It's going to print down right here. N is like a carriage return. It's just going to do a return for us. And then %g, I think g is general or generic or Gerald or Gerard. I don't know. Gremlin. But it should print out just like this. Basically, it inserts the argument that you're putting in right here. So the second one gets inserted right here, which is kind of cool because you can just like make all kinds of neat looking outputs. But you notice it's running over n, p, and I test. So okay, we have that. We have the beginnings of that going. So why don't we try doing this? Okay, so first thing we want to do, I'm going to say int has. So I'm going to make an attribute that checks to see if the second input actually has the attribute. Has attrib, and you notice it pops up for you right there. And I'm going to say the first input, which is actually the second input. It's remember it's 0 and 1 of a point attribute, and I'm going to do split x. And this will return a 0 or a 1 if it's true or false. And I'm going to say if has, which will be if it's a 1, then it'll continue on. If it's a 0, then it doesn't. And you notice, well, here, let me close this. Not close. I wanted to clear it. No. Okay. Yeah, so you notice n isn't on the second input, so it's only giving us p and I test. So that being said, let's do read equals attrib of the first input. Well, wait, we need to read both inputs. So we're going to say read to and read from, just to keep some sense of organization here. Read and from. From to. All right. Now, we need to read this from the first input. Now, to the best of my knowledge, for my understanding, you can do 0. That will give you the first input here. But to my understanding, if you use geoself, it doesn't use more RAM. It uses the RAM that's currently being occupied by the object. So it's actually better to use geoself than it is to use 0. Am I off kilt on that? I don't know, but to the best of my knowledge, that's what it is. So correct me if I'm wrong. I would like to know, but it's just one of those things. However it goes. But what we need to do is attrib the geoself. Point is the point attribute that we're reading. Split x, which is the attribute that we're trying to read from, and we need to read the pt num, which is the number of the point that you're reading the value off of. So I'm going to copy this same thing again. And it's good. Make sure you put your semicolons and everything. And you notice it didn't error out. It's setting the vectors to read from. And movie magic. All right. So ran into a slight snafu because, I'm tired. What do you want from me? Anyway, so I'm going to switch this back to inputs that have the same point count because I done screwed up a little bit on that guy. However, the same checks still apply. So iTest is not going to work. The has attribute will still pick up that the attribute isn't actually there. So if you start throwing in random values, typing in there, it'll correct that too. So what we're doing here is setting the attribute that's being found to the floats that we're setting up, the float arrays that we're setting up. Now I know the reason why we're doing this is that it's easier to just work with blending one type of attribute, because if we were to read for a float and a vector and int, it's going to be a float read from. It's going to be another set. It'll be the vector read from vector. It'll be the int read from int, and that ends up exploding everything up. And I would rather keep it nice and small. And then when it comes time for us to set the values, we'll see what the values actually are. And we can do that by doing, I think it's int of attr size. Yeah, we're going to just we're going to say attr size, and then we can do also attr type. So I'm just going to create those first. So the attribute type is going to tell us if it's an int or a float, and then the size is going to tell us if that's a float or a vector. So what we can do here is we can do all of our blending, all of our attribute sliding and blend action here, and we don't need to worry in the future. We'll just set it based on whatever the type is or the size is. So with that in mind, we don't know how big the arrays are, so we're going to just do a for loop, int of c equals 0, and then I'm going to do c is less than the length of read from. It doesn't really matter, read from or read to. You can use either of them, and it's all good to go. And then I'm also going to say plus c and go down to here. Now, what we want to do here is, let's just say read to. Let's just go read to. We're going to overwrite the values that are in here per entry. So we're going to say read to c equals. And we want to do that exact same logic that we did before. The multiply 1 minus whatever the blend, whatever the attr blend is, or the, what we have down here. Might be nice to actually just keep this open. We're going to copy this stuff up here because that just makes things a little bit more organized. I'm just going to do. All right. 2pos is not needed anymore. However, our blend value is right here. And that will update that for when it comes to attributes. And then our ramp will include shortly. You know what? I like the idea of the ramp right now. Because let's just say the values could be above 1 or below 1. Well, you know what? We'll have a toggle for the ramp to be affecting everything or not. We'll set that up shortly. I'll just get this working with the regular parameter. So we want our read from of c times, and we want to do 1 minus our blend value. And remember that's the same type of thing that was happening on the point node that I'd shown earlier. If it's 0, it's going to be the input attribute value. And outside of that, we're going to do read to, and this will be our 2 value being multiplied. So we'll do multiply by blend value. And then this way we'll be able to blend every single entry in this array, and we don't need to worry about what the type of array is or anything about it. So now that we've done that, you're already done with blending. Here's the part that I didn't want to do 3 different times over and over and over and over and over. Now the point type, check that first. If adder type equals 0, and that's an int, then we'll do one thing, else if, and we'll just copy this again. So int is 0, and then a float is 1. So we'll say if it's 1, then it's a float, and we can adjust for it that way. And we'll just do that. And I'll show you shortly why we need to set it up into 2 different ones. But if it's an int, we want to say set attrib, and we want to, if I can type, geoself, set the attribute by a point, because it's the point attributes that we are writing to. The attribute name, which is split x, so we don't know what that is. It could be anything. We want the point number or prim or whatever it is that you're iterating over. I'm just leaving it to points because that's, that's what it is. And then the annoying thing is the this is the vector, or no, the vertex. And since we're not working with vertices or anything, you just set it to 0 and you're okay. And then we want the value. And since we know it's an int being 0, we can just say read 2 and 0. And now your int can be implemented. It could be implemented. Oh, that's whatever. But I'm going to convert it back to an int so it doesn't try to cast a float as an int. I don't know that it would error, but I'm just going to assume it will. All right, so we have adder type is not set, I'm assuming, because yeah, this is doing that. So it has attribute, so I'm going to say adder type equals attrib type, like that, and we want the geoself again. The point attribute is what we're trying to read from. We're going to do another split x, and then we're going to say no, I think that's it. I think that's it. And if it's not, it'll error on us, and it'll let us know very politely. And while we're here, I'm just going to grab the attribute size. So attrib size, and I'm going to do geoself. I'm going to do point, and I'm going to do split x. So there we go. Now we're going to be able to find out if it's a int, a string, a float, or whatnot, and nothing is erroring. Ooh, I like it. I approve of this message. Whoa, what is going on there? Oh, right. I did put a randomize on there, and then it's also blending it. Ooh, it definitely looks different than it should be, which might actually be a good thing for us to know right now. All right, never mind. All right, that being said, we also have... we need to check the size. So if we do the adder size, nope, is 1. Then we want to do one thing, and that needs to be an if statement. Would be nice if was before it. We're going to do that, and then I'm going to just paste it again. I'm going to say equals 3, because you know what? Who knows? There could be float arrays, which honestly might be good to... ooh, boy, yeah, that might be good to try to update a float array, but I don't feel like going over that right now. That sounds like it's be a little annoying. You know what? Maybe that would be a good thing to try to do, but anyway. So what we want to do is we want to cast the attribute, and it's going to be a float. So we already know it's a float. Doesn't really matter. You're good here because it's already in a float array. You could just cast it. Well, that was a squeaky squeak. Now the next thing though is the vector is a little bit different, because what you need to do here is set this up as an actual vector. And I guess I honestly could have done this slightly different too. Whatever. I'm just going to leave it be. Set vector. I have enough brackets closing everything. I believe I do. Okay. Click away. Nothing is erroring that I can tell. Oh my. Nothing is erroring that I can tell. Ooh. Is it working? I'm going to right-click on this and say, no, not save. Save node type. Just to make sure it's not going to end up being a problem for us. Oh my gosh, it works. It works! It's alive! No lightning needed. How about that? But electricity was used, though. All right, now that looks a little silly if you ask me, but let's see what happens. You notice there is no eye test on the other input, so it's not reading that. I'm going to change P. Let's just see what it does for just N. Yeah, you notice that. You can blend that normal. Look at that. That's snazzy, ain't it? I approve of this message. All right, so we have the basics down. We have our blending values. You know, honestly, no. Because I was thinking it might be nice to actually have it check if an attribute doesn't exist. But if you type it in and it's not there and it just removes it on you, that'd be annoying. So I'm just going to leave that be for now. However, if I put in a space, multiple spaces, nothing's erroring. So that's good. It's breaking it out to be a nothing attribute. Well, can there even be a nothing attribute? Anyway, so why don't we get the ramp implemented here? Excuse me. Since you can go negative and positive, boy, how do I adjust for that? We could, when you go negative, actually multiply the ramp by a negative value. Because what we want to do is use this blender as where it's going to be reading from on this ramp. And if you go negative, it going negative might be a fun thing to do. You know, for the time being, let's just set it 0 to 1, and we'll see how the ramp multiplier works. Just to see how, just to see it work. You know. All right, so float. Blend value, yeah, because okay, you know what? If we overwrite this, because if we put in a check to see if we want to use the ramp, which you know what? Let's do that. I'm gonna put in a check to see that the ramp should be used. So I'm gonna go back here. I'm gonna hit type properties again. I'm gonna add in a toggle. Go down to the multiply ramp and say ramp toggle. Use ramp. Use the force, Luke. All right. All right. Ramp toggle. That's good. Apply. So this will toggle whether or not we're actually going to use the ramp. So here's what we do. Copy parameter. Oh, you know what? Just to show, make it more nice and neat. If you go down to the ramp and there's a disable when in here. So we just want to have this disable when the ramp toggle, if I can spell toggle right, equals 0. And so it'll be grayed out and you can't use it. And it'll be like, hey, I'm just trying to protect you, buddy. Just trying to protect you, buddy. And then that way you don't need to worry about messing around with the ramp thinking it should be doing something and it's not. However, that being said, oh no. I've had this happen before. Every time I try to paste it in the middle of something. Yeah. You see that? Okay. Let me undo. If you paste a relative reference at the bottom, it doesn't seem to crack. Ah, it did. Huh. It seems to be so iffy for me. Whichever. If you paste it, paste relative reference, and it clears out your entry for you, hit undo. What I would say is just hit save before doing it. I'm going to blame Houdini on that one. Anyway, so if our value, and that is an integer because it's a toggle. So again, CHI. If CHI, and again, you don't need to put something in here if it's going to be a 1 or 0. You don't need to worry. It's going to end up being a positive or a true or a false, and it'll just access it as it should be. So if that toggle box is checked, then we want to read the ramp is ch ramp, and the ch ramp is mult ramp. All right, and then we want to read it by blend value. So that will give us a 0 to 1. Well, it's not going to give us a 0 to 1. It'll the way that it reads it, if it goes off the ends, it loops back over. which, you know, might be what we want for the time being, but, you know, if you come back up and hit use ramp, ooh, it's doing a little something. But you notice it's going to be reading it based on what the Blender attribute actually is. So, but you notice it just popped through, right? Pop, 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 pop. Yep, okay. So, we could probably be smart about that and actually use it as a multiplier on the ramp itself, which might be a neat little thing to do. Honestly, might be kind of cool to do something like that. For the time being, why don't we just add another attribute that we can blend by... Yeah, you know what? I'm going to set this blend by attribute up so that we can actually see what this looks like with a ramp that's actually functioning not from reading a float value like this. So here's what we're going to do. Here's what we're going to do. Blend by attribute. I'm going to copy this, copy the parameter, dive back in, go up, and remember, I'm just going to hit save in case something bugs out again, and it cleared it, right. I'm going to copy that, hit undo. All right. And what I'm going to say, oh, we might need to have another toggle, or at least a pull down or something, so we can know what we're reading by. Because if I do blend value equals, this is going to be the attribute that we're trying to read by. Boy, if my keyboard was working a little bit nicer. I'm going to read the string of that, because it'll be the multilist, but we set it to be a string value. And I'm going to do adder, attrib. Why am I blanking out now? I think I'm tired. This is gonna go well. Oh, I could sell. All right. Point, and it's reading the point value that we have set for the pull down. I'm going to say ptnum again. And so this will read from itself the point attribute, the whatever it is that you have set, and for the current value. And that should be working if I set it to blur. So there you go. Now, is this actually going to be doing something? Yeah, it is. Okay, so why don't we make another attribute so it's a little bit easier to see what's going on. I'm going to just make another random attribute, BBY. And I'm going to read the BBY of every single point in the bounding box Y. It's a 0 to 1 value, so we don't need to worry about it rolling over, but for the sake of it, and I'm just going to read BBY. And you notice, blam! We have our ramp. Okay, you know what? This whole linear thing is kind of bugging me. Kind of bumming me out a little bit here, man. So I'm going to go back in. I'm going to edit the ramp, and I'm going to say the default interpolation as being monotone cubic. It's fine. It's a little monotone, but it'll work. Here, how about we... that should have worked, right? Monotone cubic. Why did I not want to see? Yeah, it's not highlighting it. I guess just because the node already existed. I'm just going to hit save anyway. But you notice it's reading the BBY, and based on that value is where it's reading off the ramp. So we can kind of customize exactly the movement between the two different objects. I think that's going to be a little snappy. I like it. I dig it. Ooh, yeah, man. Ooh. Okay, so, why don't we get this working so we can have a toggle between the linear blender and the blend by attribute? Because I feel like that's going to end up being more of a cumbersome thing in the future, just trying to, like, poking at both of them, It's what we'd want. All right, toggle. Do we want a toggle? Or do we want to be, like, snappy about it? You know what? For the time being, we'll just do it this way. I'm going to do a menu because I don't care. I don't care enough to know. I don't know what I'm doing. There we go. Single select, different menu items. So what I'm going to do, 0. Blend by parameter. And then I'm going to do 1. And I'm going to say blend by attribute. And there we go. If I hit apply and change the label, might be nice. And I'm going to say defaults is 0, so it'll always be defaulted to linear blend. And I'm going to say the name, blend by blend method. And here's the snappy part. You notice how I'd mentioned the disable when? There is also a hide when. So I'm going to do that. I'm going to say hide when blend by doesn't equal 0. And that is the linear blend of the float parameter. And then I'm going to do this again for the hide when blended doesn't equal 1. And so you'll end up getting this. It says blend method, blend by parameter. I'm going to set it to blend by attribute. And you notice it jumped over to BBY or whatever it is. Oh, there's a potential for this to be an issue, and I don't know how to fix this right off the top of my head. I could force it to select the first entry. So here's the problem that I'm trying to mull over in my head right now. When you dynamically generate a list like this and you have no selection, it's kind of annoying that you need to click on it but to actually like activate that you have it selected. Even though it will list whatever the first entry is, you need to like click on it for it to actually read from, which is kind of annoying. You can read the values off of the pull down menu, but I don't know how to select the menu. Yeah, this is going to take some digging. I'll put it in the comments below. I'll just update the Python. I apologize that I don't know it off the top of my head because I'm trying to remember. I just can't right now. But time makes fools of us all. So I'm sure in like 10 minutes I'll be like, oh, right, it's that way. You select the menu item. No, exactly like that. So if you just copy the parameter, we're going to read by whatever it's trying to blend by. So I'm going to jump back in. And again, it's probably going to blank out on me just because this has been that type of night. I'm going to do paste relative reference. Yeah, exactly. Oh, jeez. Undo. Okay. If blend by, and this is going to be an integer because that's the values that we're reading by. If that equals 1, and 1 is the blend by attribute, and we are currently, if it's the first selection, it won't do this. Ooh, we need to make a bracket in there. All right, if it's the first selection being 0, it won't read the attribute. If it is a blending by the second being the first entry, I'm trying to explain that on like a normal basis to other people. It's like, oh, it starts at 0, but it's the first one, even though that's actually the second entry, but the second entry is actually the third entry. You know what I mean? So if it's set to by attribute, it'll read by attribute. If it was set to 0 here, then it would bypass and read only the linear blend here. So let's just double check it that this is actually working the way we want it to be working. Well, I mean, so far so good, but then if we switch it back to linear blend, woo, yeah. All right. Now that thing that I was trying to consider, setting this up to be a positive and negative blend, and let's say even multiply, because if you start going into the negative values, potentially good. Okay. Here's what I'm going to do. I know that was probably a ramble that made sense in my head because the train of thought is in my head, so it doesn't exactly help that I'm not speaking articulately. All right. We want this, the blender, the linear blender, when it goes negative, to be a negative blend. But you notice right now it's popping. And then once it goes over 1, you notice it popped again. We want that to be the multiplier. We want that to be like going over the top and back, you know? So here's what we're going to do. Listen very carefully. All right. I'm not drunk, I swear. If we dive back in, and we have our attribute value, potentially also this attribute value could be any number of directions to go in. So here's what we're going to do. I'm going to set up another attribute of ramp read. Read ramp. Ramp read. Whatever. Doesn't matter. You set it up however you'd like. Of the value, but I'm going to do the absolute value. So when it goes negative, it'll still be as though it's 0 and then down. So it'll start from 0 again, because you notice it popped. Yeah, if you notice once it hits 0, it pops as though it's back to 1 again. We want it to be as though it's 0. So if we get the absolute value of that, it's going to be back to a positive 0.03 in this case, rather than negative. So if we dive back in, and I'm going to do something called sign. I think sign is just an int sign. And what sign is quite literally, sign, is the sign of whatever the value is. And what I mean by that is if the value is here, you know what? I'll do it for you. I'll make it simple. I'm going to print f, and I'm going to do that, /n and %g. I'm just going to do sign of -10. And I'm going to do the sign of 0. And then I'm going to do the sign of huge ass number. I don't know. But you notice it just prints out -1, 0, 1. It's quite literally the sign of -10 is negative. The sign of 0 is 0, so that's not fun. And then the sign of is 1, or positive 1. So we can use that value and multiply it. And why are you erroring? Maybe it's not actually an int. It might not actually be an int that it's supposed to be returning. So what's that? Float to int. Huh, it's a float value. That's an odd thing. You know what? That's fine. We're working with floats. So we would want that to be a float nevertheless. So this is a good thing. Yes. Yeah. Okay, cool. So here's what we do. Now that we have it, that the blended value is going to be absolute, but we also want it to be between 0 and 1. So it's an absolute value, so it's always going to be above 0. But we want to take the minimum of that, which will be either 1 or whatever the absolute value of the blend value is. Basically, that keeps it between 0 and 1. Now, the reason we're doing that is because after that, we can multiply it by that negative value or the positive value. And so just for the sake of it, let's just do that right now. I'm going to say times sign. And the other thing that I want to do with this, because we can go over the top, and this is just going to be a multiplier, a blending value anyway, we can say that blend value, we can say, oh, well, do remember ramp read, we need to update where it's reading here, so ramp read. And we're going to say the absolute, nope. Here's what I'm going to do. I'm going to add the blend value. However, I'm going to subtract 1 because it's going to be reading a 0 to 1 value from the ramp already. And I'm going to do the max of 0. So if the parameter or attribute that it's trying to read is above 1, it'll subtract 1, so it starts at 0. So once it starts adding it, it's only adding that value when it's above 1. So if you push it to 2, it'll add that extra 1 on top. So this potentially could work out for us. Potentially. Let's see what's going on. Oh my gosh, it's going negative. Yeah, the simple things in life sometimes are the most fun. Whoa, the normals are going all haywire in there though. So we now are invert blending the point position, the N, and just for the sake of it here, I'll update our BBY and I'll say multiply by 3 or something, and we can see what this looks like. Multiply blend by attribute. BBY was already set because we set that before. Oh my, that's looking crazy though. Is this what we want though? Is this actually the type of result that we want though? Because it's going over the top, but this is 0. So unless we multiplied it and added it on top, maybe. So it's a multiplier, right? All right, it's a multiplier. That's fine. We're just going to change this up a little bit. I don't want this to always be driving over the top because the ramp was 0 here. This should be 0. That's just how it should be, or how I think it should be. So what we're going to change here is we're going to say max 1, and this blend value of subtract 1, I'm going to take that away. I didn't know that I wouldn't like that. However, we're no longer going to be adding it. We're going to be multiplying it. Now, what this is going to be doing is once it goes over that 1, it'll multiply whatever the ramp value is by that value. So it should, when I click away, go back to 0. Then if I come back in here and raise this up, you notice it's multiplied by 3 rather than that 1. So here, let's just change this back. Change the BBY back. And you notice that's just what the bounding box Y would be blending to. I know this is probably getting a little bit long, maybe a little long-winded. There was one more thing that I wanted to show you how to do, or potentially try to do. We have 2 different objects. We have a sphere and a box. It is freaking out. It's just a happy little box here. But once it tries to start blending, Nelly, it does not have a good time. Does not like it. And it's tomorrow, or the day after I started recording the first part. And I realized the video is already very long, but I wanted to show you how to convert basically 2 different inputs that are the wrong point count, 386 by 252. Now, to just try to get it more of a precise, like, connection between the 2 different objects. Now, I was a little becoming of myself and moved this off of center a little bit up here. Now, what we're going to do is have this become the sphere, no matter where it is in space, on top of really trying. I mean, like really trying to become a sphere. You're working with 2 different types, 2 different point counts, 2 entirely different geometries. It's not going to be perfect. Just a heads up in the first place. But if you have two different geometry objects that are similar to one another, this will get you some of the way there. So what I am going to do, I'm going to put down a switch node, and I'm going to just drop this in. I'm going to have the first connection. Ooh, you know what? Before I get all this, I'm going to put in a null. And on this null, I'm going to just say in. And this will make it a little bit easier for us to read values without getting too convoluted. And I know this whole node is already a bit off. The heck? No, in and off? No, I'm going to go 2. Yes. Yeah, I'm just going to name it 2. I don't know where my head is right now. So I'm going to connect these up in the first input, or the 0th input is going to the 0th input of the switch. And then the second input, the 2 object, is going to go into the second input of the switch. Now, we need to check just to make sure that if the 2 objects have the same point count, it's going to read in the 2 object no matter what. It's just going to bypass doing any of our like fancy schmancy little stuff here because we don't need this to happen. So what I'm going to do is read to see that the point counts are the same between them. And if I do points, endpoints, you can read, let's say if I do ... which is going to be like the parent of the current node you're working on, the parent like network, and that way I can read the in node. With that, it'll give me the point count of what's coming in on the first input. Now, if I say that's equal to the endpoints of the second input, which is 2, remember that, 2, then if that matches, it will read from the second input. But right now we have a box coming in the first input and a sphere coming in the second, 2 totally different objects. So, of course, it's going to be reading from the zeroth input. You know, just for the sake of showing you. What I do? Okay. For the sake of showing you, I connected the same input in, and you notice it's reading from the second input now. So that's working. Just make sure, on your end it's working. Good to go. Good show. All right. So what we're going to do here is basically make sure the object, and you know what, just for the sake of, I'm going to turn on template so we know where we're working. I'm going to make sure the centroid of this box is on top of the sphere. And you know what, just to make it even more complicated, just so you know it's working on your end, I'm going to add in a transform node, and I'm just going to move this somewhere in space as well. It's not at 0, 0, 0, which makes it a lot easier to transform an object if you don't have an offset to account for. So we have two different objects, two different offsets, and we want to basically get them on top of each other and, figure out a good way of getting them onto each other to be the right shape. So I'm going to put down a transform node. Now this, I can take the centroid of the current object we're working with and subtract that from the centroid of the object we want it to connect onto. So that way we can basically get it on top of the object, and that way we can blend between two objects anywhere in space, and you don't even need to worry. You're still going to have to worry, but it won't be as bad. I know the amount of confidence I have in this is a stellar confidence on here, right? Just to put everything down real quick, I'm going to say CEX, CEY, and CEZ. Now, this is getting the centroid of everything, and you notice it's subtracted, or it's adding, sorry, so it offset it from the 0 into space. Now, that's, you don't need to worry. We're using this as an offset. So what we do is read the centroid of the sphere and then subtract the CEX, CEY, and CEZ. So I'm going to do centroid, and you notice it just pops up for you when you start typing that, and then subtract the CEX. So here's what we put into the centroid. Ooh, excuse me. You do ... same thing that we did on the switch node. And then in here, the help shows up that you can see it's a D_X, and that is the centroid X of the object that we're reading, which is the 2, which is the sphere in space. So if I do that, you notice it just moved the box for us, and it aligned it with the sphere. So if we do this again with the Y and update the DX to be a DY, and then we do it with the Z, and we say the DX to be a DZ, and you notice it snaps it directly onto the sphere. That is the centroid of the sphere. And I guess if you have more complicated geometry, here, I'm going to leave this pinned so you can see. If you have more complex of a geometry, maybe this might not be 100%, but it'll get you close enough to hope for something. And you notice I'm trying to move that box. I am trying to move the box. If I move it in space, you notice it's moving in space, and if we go in here, the box is still at the centroid. Okay. I did something weird. Yeah, if you ever see it go yellow like that, it means that you tried to offset something that is currently set to an expression or animated. So if you just change the frame, it'll reset that for you. You don't need to worry. But it's currently going to the sphere center, no matter where it is in space. That's great. That's kind of where we want to begin with. But, all right, the next step would be, I'm just going to do a ray. Simple little ray. And that way we can get it to kind of merge onto the geometry. And if we view it, boy, it doesn't look very pretty, but it's becoming a sphere, honestly. It's doing something. I mean, it's close, but it's still not going to be good. Now, let's say for the sake of trying, we have our, I'm going to unpin the viewport again just to show. Let's say for the sake of trying, we start to scale the object, and you notice the box starts coming out of the sphere. So if you project the ray, if you project by the normal rays, some of them will work and then some of them won't. And there's going to be a reason why I leave it as projection ray, because at least that way it's actually going to where it probably should in space once it's actually colliding with that other object. Now we can address the issue of the points that are outside of the sphere. Ooh. Sorry about that. Now, there's something, if you use on the ray node, if you use point intersect distance, if you hit check mark on that and check your geometry spreadsheet, and then just go to your distance, you'll notice that there is some numbers in here, but there's a whole bunch that are zeros. By default, the point intersection distance will get a 0. However, if we make a new attribute, not attribute copy, attribute create, and we make an attribute on here that is dist, and set the value to -1, and you check out your ray again, you'll notice that you have -1s. I don't see any zeros in here, but there is a chance that if a point is already on the object, it'll get a 0, and you don't need to worry. Yeah, I'm not seeing any zeros in here. So whichever. It don't matter. It don't matter. Yeah, there's no zeros. Whatever. Doesn't matter. So we're actually going to then adjust the points that got a 0, that didn't move on this ray. And so you could do that by doing another ray. And I know this is a whole bunch of raying on top of a raying on top of raying. But you know what? It ends up being... it'll get you close to the object that you're trying to shoot for, at least. I'm going to switch that to points. I don't think I did that on the other one. And you know, it doesn't really matter because it's entity. It works. However, so that being said, being the entity of points for the group will be used, that I'm going to use an expression. I'm going to say dist, that attribute that was just generated, if that equals 0, affect only those points now. And we could do this in a couple of different ways. We can say reverse ray, and you notice that's kind of working. I'm kind of thinking that geometry looks kind of funky, and I'm almost imagining that it's going in on itself. Like this point is facing the other direction, these points are facing the other direction. So I'm actually going to change it from projection arrays to minimum distance. And you notice that weird, like, collapsed position. Like if I switch it back to rays and switch it to reverse, you know, it looks like weird kind of collapsed triangle. And then if you switch it to minimum distance, you know, notice it kind of fixes itself. So with that being said, the first ray will be just a regular projection rays, and then the second ray will be our minimum distance. And you know, honestly, it looks pretty close to that sphere. Like I'm pretty content with that. I mean, there's probably some things that we could probably adjust here to make it a little bit easier. I have an idea. I'm gonna hit save. How about, and then I'm actually gonna hit save on the node, right click and just hit save node. I'm gonna make it a little bit more complicated geometry, so it's a little bit more noticeably incorrect. So I'm gonna say tube. I'm just gonna put down a tube. I'm gonna set it to polygon, and I'm gonna make the end caps. So if you view it, you know, it's like this, and then I'm gonna move it in space again, so we can just double check. Always double check everything. That the object is trying to merge onto it. Oh, honestly, doesn't look horrible. It doesn't look very good, but it doesn't look horrible. You notice that these points are kind of getting a weird shape here. So what I'm thinking is we can offset the points to adjust, to try to merge just that little bit better onto the object. So how am I going to do this? I'm going to set up a VopSop, or point vop. I'm sorry. I'm so used to it being just VopSop. I'm going to put the first input, tuboid kind of shape, or cylindroid shape. And then the second input of the point vop, I'm going to put the second input of our, like, HDA, the 2. And then that way, I'm just going to hit save again, and that way we can find the closest point on the actual object and try to merge it onto that object. So here's what it potentially could look like. I'm going to say near point. And there's a few different ways that we could do this, but near point is just the simplest. It just finds the closest point to the current position in space. And I'm going to connect that up to the position of the point that it's currently iterating over in this point vop. And I'm going to connect the input into the op input 2, which is the R2 object. It outputs the point number that we want to read from. So what I'm going to do is import point attribute. And by default, it tries to read point position, but I'm going to connect the endpoint into the point num, and I'm going to say the file is our op input 2. Now, if we just input this into our point output here, you notice it becomes the cylinder. I mean, full on. That's not exactly what we want, because you want to be able to have, you know, some geometry where it's like in the middle here, because if everything merges onto a point, could be a little cumbersome. I'm not a huge fan of this idea, so why not? Here's what I'm going to do. I'm going to, in here, I'm going to add a ramp attribute, and with this, we can add a fall off from where the current point begins and where it ends up. So the current point position and then the target position. So if we just change the ramp type to a spline ramp, and you notice it's a linear float kind of ramp, and we just go up to the top node, and you can even see it sets it to 0. You can even see that, you know, it doesn't do anything right now, but we're going to connect that up, and I'm going to just change this to blend ramp, whatever, real original, right? So the current running lesson of this video is basically we're going to set up a blend, right? So there's a couple of different ways we could do this. The easiest is just getting the distance. Yeah, we're just going to get the distance from our original point to the target point position. And that will be, I don't know what that'll be. Hopefully, if it rays and the object has enough, you know, detail within the resolution of the actual object, how many points it has, it won't be that far off. So with that in mind, I'm just going to put down a clamp. You can always add something to this for yourself, like a dividing factor or a multiplier or something, just so it's a little bit easier to customize the fall off. And I know I'm kind of rambling on that because that probably doesn't make much sense. Because if the value is over 1, the ramp is just going to read the max value no matter what. And so if you can multiply this value down, it might make it blend a little bit easier. However, what does that blend mean? What am I talking about with this? So we get the distance, get the clamp, get the ramp position, and we're going to need to do that same position blending between where we currently are. So I'm going to put down a mult node, and with that, I'm going to multiply by the current position. And so this becomes a percent value. So I'm going to just multiply the ramp by the current position by the ramp. And so we need to do this also by the point position it's trying to target. So we're going to put down a complement node. And a complement node is simply a 1 minus the value it's going in it. You can even see it says 1 minus x. So I'm going to then connect up. Not that. Don't do that. I'm going to connect up the ramp output into complement, and then I'm going to multiply that. The same thing that we did on the input node. So I'm just going to like drop that in there. And then complement, I'm going to multiply the point position it's trying to go to. And then I need to add the two of these together. So what this is doing for us, it is basically doing the same thing that we're doing through Vex on all of our other point positions. So just add the two multiply nodes together with an add node and put your output. And what this is doing is using that ramp as a fall off curve. So if we start to adjust the ramp down, you notice it's really pulling it back. And then if we just try to blend it a little bit, I'm going to change this from the monotone cubic again because I don't really care. I mean, B-spline looks nicer, honestly. I should probably be setting it to be B-spline, but I don't care enough right now. If you want it to look nicer, use B-spline is the nicest that you can get. So if you start playing around with it a little bit, you can notice that it's like trying to keep more of that cylinder shape. And it is getting a little wonky, but you notice it's getting closer to the shape it should be getting. And, you know, with this in mind, if we do a slight smooth, yeah, if we do like a slight little smooth, I'm just, you know, just to get it, make it a little bit more relaxed. You know, it's a little easier going. Yeah, yeah. See, it's a little nicer. It's a little easier. Whoa, what's going on there? There's like another set of geometry in there. What's going on? What is going on? That's weird. I don't get that at all. Why is that doing that? Oh, please don't tell me it's just like a geometry error. Yeah, that's strange. What is going on here, buddy? Okay. Whatever. Okay, I just pop back out and pop back in. But you notice it, that tiny little bit of a smooth, which I honestly might be a little bit too much of a smooth, can get us really pretty close. Ooh. Just make sure the filter quality is set up just that little bit. And you might want to just leave on group boundary. Nah, you know, that's not going to be very good. If you have any cusp faces, any open holes in the geometry, leaving the constrained boundaries set to group boundary will leave hard edges for you, which might not be what you want. I'm just going to set this to none. That way it'll smooth just that little bit. Uniform blend, I'm just going to leave the strength a little bit, and just to top it off, because it's still not perfect, is another ray. I know this is like overkill on the rays over here, but honestly, we're merging two different geometry types that don't look anything like each other. So just for the sake of it, would be nice. I'm gonna set entity to points again. Doesn't really matter. But the method I'm gonna set to minimum distance, and then that way, it's gonna be it's gonna be close. It's not perfect, but it's gonna be close to the object that it's trying. Like that really, it's really not 100%. If we dial down how much smooth that we are putting in here, it'll try a little bit better. Just that little bit better. You can always try changing between uniform. It's not going to be as good on curvature or on scale dominant. Scale dominant. I mean, it's good. Maybe this might be what we want, but it's the points are still like staying on top of each other, which I don't like. I'm just going to use it uniform and just dial down how much smooth there is, around 5.5 or so. And I know it's not perfect, but it's pretty close. I mean, this one is definitely on it. This other one is kind of close. Either way, you're merging two different objects that have two totally different geometries. So I guess that happens. That being said, however, if we import attributes from hits, we need to read, well, I guess we're trying to read the blend attributes that we're blending between. So it's whatever this blend attributes is. I'm just going to copy that parameter. And on the import attributes from hits on the same ray node at the very end, same ray node, I'm going to just paste it, paste relative reference, and blam. So it's going to attempt to read whatever the values are that we're setting here. So you'll be able to notice a little bit better if I add a normal node and set this to a point normal, and put this in here. You'll notice that you'll even see that the points blend to whatever it's attempting to achieve. But that's because this is what we're trying to blend. We're trying to blend the normal, so it's attempting to get the normal. And I know if we view the tube, it's a kind of a strange looking set of normals, but this is about as close as you can get with something like that, right? However, nevertheless, if I go back down to our attribute wrangle, which is down here, we can see that if we blend our blender, it goes to that point. However, the problem is if you go over, you shoot it over. It's sort of intending it to be 0 to 1, or you can do a little bit under. And I know that kind of gets a little bit strange, but if it's merging two different objects together that have two totally different geometry counts. We're turning something that has 386 points into something that has 24 points. Honestly, I think that turns out pretty well for something that has 24 points. All right, so I'm going to hit save. Save on the node, right-click, hit save. Now, the last step before you finalize your HDA, last step. Well, okay, there's always last steps, but a step before you finish is just drop the node. Like, completely Attriblender. Why do I have 2 listed? Attriblender, drop it down. And when you drop it, you notice it has an error. That's annoying. However, none type object, no attrib. And it's a traceback. I'm going to send it to the console because it might return a little bit more information for us. Like right here. Oh, wow, a whole bunch of them. Right here, it says error running Python menu script. All right, so that gives us a little insight into where this problem is coming from. So none type. I mean, there's nothing connected to it. So just for the sake, I'll show you. So just for the sake, type none type when we drop it down. What you can check first, the basic, just make sure your minimum inputs and your maximum inputs are set to the proper values. So those are already set just fine. Because whenever you make a subnet and turn that into an HDA, it records how many inputs are connected already. So it'll set that for you automatically. So the problem is arising from the actual blend attribute menu, and I'm going to assume the blend by attribute menu because there's no connections going in. While it should only error because you don't have any there's no input, so it should be just the minimum input error. It's also erroring because it's trying to read geometry that does not exist. So that's not fun. I'm not a fan of that. I am not a fan at all. So here's what we're going to do. Here's what we're going to do. We're going to check just to see how many inputs there are. And if we do the len of n.inputs, this will give us a list of the inputs that are coming in, but then the length of that is however many there are. On this current node, there are 2 already. However, we want to make sure there are 2, and then if not, throw an error for us. So it errors through the pull down menu and not through a Python error. I promise you, it's a lot easier doing it this way instead of allowing Python to just error out incessantly, and it is incessant. However, okay, if the length of n points is equal to 2, then do what we've set up our script to do. We'll just grab it all and hit tab. But if it's not, else we're going to return 0 and set, in quotes, set inputs. I don't know. It's whatever you feel like doing. However, we need to do this on both the blend attributes menu and the blend by attributes menu. So I'm going to do that here. I'm going to tab this out again, give it a little bit of room for us. And that's like that. And then I'm going to copy our set inputs, copy that, and paste it down here. And I'm just going to hit apply, hit accept. And just to test it out, I'm going to blow away the inputs. And you notice it's erroring. But if we go to the pull down, set inputs, because it errored out. Oops, not that. Blend by attribute. Set inputs. It's telling you to do it. You got to do it. And then if we connect 1 in, it's still asking you to set some inputs. And then if we connect them both up, we have a cross check. Oh, success. So, why don't we just try it again? Attriblender. Where are the Attriblender? Why is it showing up twice? I don't get it. I don't get it. All right, it's still erroring. However, the error is not enough sources specified, which is nice because it's not just a Python error, which will pop the window up multiple times over and over and over and over, and you need to like keep clicking it or send it to the console, and it's not. It's just, it doesn't want to. It doesn't want to listen to you. You're not its father. Come on. On that note, you can just test around to see what it's doing. And honestly, this is kind of neat, isn't it? We're currently trying to blend to an object that doesn't exist. I'm seeing a little bit of popping in there. That's not fun. That's not fun at all. I mean, I guess that's just what's gonna happen when you're trying to blend to an object that's all over the place like this. You know what? I have an idea. I will show you in another video how you can correct for that using a new node. That will be the next video I make, will be a point animation smoother. How about that? That'll be a fun one. All right, this video is probably huge, and I'm sure this is not something. What? Oh, that's not what I want to do. Preview. I'm sure this has been long-winded, and just for the final top off, I'm gonna say from Geo and to Geo on our input outputs tab that we're editing. And if you hit apply and hit accept and you hover over one of the inputs, it'll say from Geo, and the other one it'll say to Geo. All right, so that is the Attriblender, and this is Kevin Adzanga showing you some random Python, Vex, and Houdini nodes. I hope you learned at least something in here, and if not, correct me in the comments. Just please. Oi. Yeah, if not, just correct me in the comments. You know, that's how it goes. Have a good night.